Good day, I am Gian Duhina from course ECEA103 section B14 presenting laboratory experiment 8, which is the project slash design problems. It is a partial requirement for the course subject together along with our course advisor Sir Joseph Brian Ibarra. So to tackle the laboratory experiment 8, here are the objectives: to design programs based on written description and requirements, to demonstrate skill in devising, programming, executing, running, and troubleshooting of programs. The task was given a written set of instruction related to an industrial process or operation. Draw the function block diagram, identify and select the necessary components, lay out the I/O wiring diagram, interconnect the components, program the PLC, and demonstrate and document the operation of the project. So the project was a stamping device. The description: the rectangular block are stamped into a machine. Once the start push button PB1 is pressed, the workpiece is fed into the machine by cylinder 1.0 from a gravity feed magazine and is clamped in place by the same cylinder. Next, it is stamped by cylinder 2.0. After stamping, cylinder 2.0 retracts, followed by cylinder 1.0. Once the workpiece is fully declamped, it is ejected by cylinder 3.0. So for the I/O assignment, the address, I/O device, and description are stated. For the 0.01 address, the I/O device is PB1 or the normally open NO push button momentary switch. For the 0.02 address, the I/O device is S1 or switch 1. The description is 24 VDC capacitive proximity sensor, and for the address 0.03, 0.04, 0.05 are respectively as S2, S3, and S4, switches 2 to switches 4, that has the same description of 24 VDC capacitive proximity sensor. So for the address 10.01, 10.040, and 10.070 has the I/O devices respectively for Sol 1 or solenoid 1, solenoid 2, and solenoid 3. And for the solenoid 1 to 3, the description, all of their description are the same for 24 VDC solenoid valve. So now, we will create the EP wiring for the 3-cylinder, namely as cylinder 1.0, 2.0, and 3.0. Now, we will create the I/O wiring. Now, we will create the PLC diagram in the logic module here in our fluid sim.